Hey everybody, this is Trigonometry at College of the Sequoias. It's Math 154 for us. This is the second section. For us, it's chapter 5.2. For you, it might be 1.2 if you're at a different college. But let's do a little warm-up first. Let's get you back into thinking mode. And it's a word problem. Let's look at revolutions of a disk. Or like a DVD, Blu-ray. So some fun information. DVDs spin at a constant linear speed. Linear rate. The inner part of the disk, inner spin rate, it does 1,530 revolutions or rotations per minute. And the outer edge, it has to cover the same amount of distance, but the distance is much wider there, or longer there, so it goes slower, 630 RPMs. And it reads different portions of the disk at different times, so it speeds up, slows down, to read at a steady rate, depending on where it is on the disk. So that's how it works. When reading the outside edge, through how many degrees does the disk rotate or turn in 4 seconds? So RPM, this is either revolutions or rotations. They mean the same thing in terms of a circle per minute. RPM. So we have 600, I'll let you pause and think about it. Make sure you pause it. If you want to work on this, try to figure it out on your own. We have 630 revolutions or rotations in 1 minute. And we need to end up with degrees per second. So we need to get rid of minutes. 1 minute has 60 seconds. And that cancels out the minutes thing. And now we got seconds. We need to get rid of rotations. One rotation does 360 degrees. And now we're out of rotations. Now we have degrees per second. 630 times 360 degrees divided by 60 seconds is 3,780 degrees in 1 second. But we didn't want 1 second, we had 4 seconds. So 4 seconds, we have 3,780 degrees in 1 second. We multiply by 4 seconds. That gets rid of the seconds. And all we're left with is degrees, 15,120 degrees. Okay. So that's your warm up. Get you thinking about degrees again. Pause it if you need to write this down. This is similar to a word problem that will appear in the homework. And now 5.2. 5.2 is on trigonometric functions. I like saying that, trigonometric. It sounds nice on the tongue, but it takes a long time to say. So generally, we just abbreviate it to trig functions. To start you off, I want you to recall something that you know. Recall the Pythagorean Theorem from algebra. It was the triangle one, remember? A, B, and C, and it makes a right angle. A squared plus B squared equals C squared. Now, when we shift this to trigonometry, we're going to treat A as the initial side in standard position. And C as the terminal side. So I'll redraw that. So there's my x-axis, my y-axis. This is side A, B, C. This is making an angle theta. Well, clearly, if we have this as 0, 0, this point here, whatever that length is, let's call it x. That point is x comma 0 if this length is x. If this length is y, this point is x comma y. So we have x equals a, y equals b. And since we're rotating this and this can rotate in a full circle, for C, we use R. And the reason why we do it, for a full circle, (360 degrees), C is the radius, and thus R. So our formula, Pythagorean's formula, turns into a squared is x squared, b squared is y squared, c squared is r squared. And if we want to find R is the positive square root of x squared plus y squared. To get you thinking, why not use R equals the negative square root? Because when we take the square root, it's the plus, positive or negative one. I'll pause and let you think about that for a second. Pause the thing if you need to. Try to think about this. Why would we use only the positive one? Well, R is a measurement. It's a distance. And negative distance doesn't make sense. When I drive to work, oh gosh, what is it, 4 or 5 miles? 4 miles to work. Driving home is not negative 4 miles. It's always a positive thing. All right. Pause it if you need to take some more notes. So we have 6 main trig functions. The 6 trig functions are we have sine, cosine, tangent. When we abbreviate this, we use the first 3 letters. And it always has the angle in parentheses. Angle theta is part of the trig functions. Okay. Now it looks really lazy. If you look at sine, all they did was took off the E. And now it says sin. Now the reason why is, well, cosine and tangent get shorter, and the other trig functions also get a lot shorter. We also have secant, cosecant, and cotangent. Now here they use the first 3 letters for 2 of them. We already have a COS, not just our school, College of the Sequoias. This is COS, so they use CSC. These are our 6 trig functions. These are the primary ones and the most important ones to know. And there's a reason why there's a relationship between the other 3 and these 3. So if we have a triangle, with an angle theta, and this is X, Y, and R, sine of theta is the opposite side over the hypotenuse. O over H, or opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. A over H, or if you like using the 3 letters, helps make it clear what it is. Adjacent means next to. Finally, tangent theta is opposite over adjacent. I put theta down, O over H, opposite, oops, over adjacent, O over H. If we look at our pictures, for theta, the opposite side is Y, X is the adjacent side, and R is our hypotenuse. So sine of theta is opposite over hypotenuse is Y over R. Cosine of theta is adjacent over hypotenuse is X over R. And tangent of theta is opposite over adjacent is Y over X. Now the reason why I did these letters, there is a common acronym for this. Sine is OH, SOH. Cosine is A over H, CAH. And tangent is O over A, TOA. SOHCAHTOA. That's what they call it. SOHCAHTOA. So I'm going to pause this to write down what you need. I'm going to copy down some of this information on the next page because we're going to use it to talk about the other three trig functions. So what did we have? Oh, I don't know if you can hear my dog yapping in the background. Sine theta was y over r. Cosine theta was x over r. And tangent theta was y over x. Let's say that's A, B, and C. To find the other three trig functions, use the reciprocal. And what do I mean by that? Well, let's flip it over. Flip it. Flip it real good. Ah, flip it. That's whip it. All right, so if I flip sine theta, this is like sine theta over 1. Flipping it over is 1 over sine theta. Flipping over y over r becomes r over y. And 1 over sine theta is cosecant theta. If we flip cosine, we have r over x. This is secant theta. And we flip tangent. We have x over y. And this is cotangent theta. You'll notice my t's, I put this little tail on it like typewriter. I didn't up here. This looks like a plus sign. So when I'm writing the trig functions, I try to put a little tail on it. The way I remember it, which one goes which way? The way I remember the reciprocals. One, cotangent has the word tangent in it. So they're linked. 2, use the other first letter. Between S or C. And what I mean by that is S goes to C and C goes to S. So sine doesn't go with secant, sine goes with the other first letter, C, cosecant. Maybe I'll write that down so it's in the notes too. Sine theta starts with S. So use the one that starts with C. Cosecant. Obviously not the cotangent one, that already is with tangent. Cosine theta starts with C. Use S, secant theta. Pause it for a second. All right. I do want to point out, quick note. In algebra, 1 over x is the same thing as writing x to the negative 1. This notation does not work for trigonometry. as is for trigonometry. One over sine theta does not equal sine to the -1 of theta. 1 over sine theta, if you want to write it with the inverse notation, you have to do sine theta and put -1 on the outside. Sine -1 of theta is the inverse of sine. This is the reciprocal of sine. Okay? Now, there is more stuff that goes together. Let's take a look at sine theta over cosine theta. This is y over r divided by x over r. And when you divide by fractions, you can do the same thing as multiplying by the reciprocal of the denominator. But the r's cancel and we get y over x. And that's just tangent theta. So tangent theta is sine theta over cosine theta. The same thing happens with cosine on top. Multiply by r over y, we get x over y. This is cotangent theta, and that's cosine theta over sine theta. So there's even a relationship. If you get sine theta, cosine theta, you can get all of the rest, which is convenient because we're going to have a tool to memorize all of the most common angles for sine and cosine in degrees and in radians. Okay. These two are called the quotient identities. If they mention the name of the identities, that's what they're called. These are the quotient identities. The ones on the previous page, I believe these are called the reciprocal identities. Let's look at some examples. Pause it if you need to. Okay. Our first example. We have a point at 8, 6, and a ray going to it from the origin. This makes the angle theta. Find the 6 trig functions of theta. I'll pause and see if you can figure this out on your own. I haven't gone over it yet, so you may or may not be able to. The key here is to picture it as a triangle. Okay? Pause it if you need to. And I'll assume you did. What I'm going to do is I'm going to make a triangle by dropping a line so that this makes a perpendicular line. So that makes this side here y. This side here is x. And conveniently, that's x and y. So y is 6, x is 8. What about r? X squared plus y squared equals r squared, or you do r as the square root of x squared plus y squared. 8 squared plus 6 squared equals r squared. That's 64 plus 36. Adds up to 100. The square root of 100 is 10. So r equals 10. And now we can find our 6 trig functions. Sine of theta is y over r, which is 6 over 10. And we don't want to leave it at that. We can reduce fractions when you can. This is 3 over 5. Then we've got tangent of theta, or cosine of theta, sorry. X over r, which is 8 over 10. And that reduces to 4 over 5. And finally, we have tangent of theta, which is y over x. 6 over 8 is 3/4. If we flip these over, we get the other ones. Cosecant theta is 5/3. Secant theta is 5/4. Tangent theta, or cotangent theta, is 4/3. Note this corresponds to a triangle that's 3, 4, 5. Or if I go up here, so that's 8, this is 4, that's 6, this is 3. The whole thing is 10. This short part is 5. I have these backwards. This is 3 and this is 4. That makes this 8, this is 6, and this full length is 10. These are called similar triangles. In fact, this is a very, very common triangle. Architects and engineers call this the 3, 4, 5 triangle. And you can get the other ones just by multiplying these by different numbers. 6, 8, 10, 9, 12, 15, all have the same information. Ready for more? Pausing to give you time to write, for me to take a couple pills. Let's do another example. The terminal side of an angle theta ends or passes through the point -8, -15. Find the 6 trig functions. Six trig values of theta. All right, so pro tip, draw a picture. Pictures help. So x is negative, y is negative. We're down here. That's x, this is y. -8, -15. I'm just estimating where it is. That's my angle theta. Quick question for you. quadrant is this? Remember, it goes 1, 2, 3, 4. This is quadrant 3. All right, so back to where we're at. Finding the trig functions. What are our values here? X is right out of the coordinate system, so is Y. If we want to find R, well, let's do some work. R is the square root of -8 squared plus -15 squared. The negative goes in the parentheses. This is 64 plus 225. So R is the square root of 289. Slap that bad boy in a calculator and it's 17. I'm going to put a box around that because I'm going to need those to do my 6 trig angles. Sine theta, again, is O over H, which is Y over R, -15 over 17. Cosine theta is A over H, which is X over R, which is -8 over 17. And tangent theta is O over A, Y over X, which is -15 over -8, which is 15/8. The negatives cancel. Find the other ones, we flip them. Sine goes to cosecant, -17 over 15. Cosine goes to secant, -17 over 8. And tangent goes to cotangent, 8 over 15. Pause for a second there. See if you're ready for some more fun. I hope so. Let's do it. Let's do it to it. Shit in my pants got uncomfortable. All right, example. Given the line 2x minus 3y equals 0, find the 6 trig values if theta comes from standard position. This is a little bit more challenging. We need to graph that line. We need a picture, so we need to graph it. So how do we do that? I like solving for y. Y equals mx plus b. So I'll subtract 2x from both sides. And I'll divide by -3. And I get y equals 2/3 x. M equals 2/3. Rise over run. It rises 2 and it runs 3. From standard position, that makes that theta. Y here is 2. X here is 3. Let's find r. Notice I keep flipping back and forth between whether I use the square root version or the base version. You should be comfortable with both. This is 9 plus 4. So r is the square root of 13. Not a friendly number, is it? So let's look at our trig functions. Sine theta. I'm just going to write down my values. X equals 3, y equals 2, r equals square root of 13. Y over r is 2 over square root of 13. We don't leave it like that. We don't leave radicals in the denominator. So we get 2 root 13 over 13. Cosine theta is x over r, same process. Tangent theta is y over x, which is 2/3. We flip them. Might as well use these ones to flip. Cosecant theta is root 13 over 2. Secant theta is root 13 over 3. And cotangent theta is 3/2. Note, this is just m. M is tangent theta if the line passes through the origin. Zero, zero. Okay. So those are them. Let's look at the quadrantal angles. Pause it if you need to right here. Okay. So the quadrantal angles. Zero, 90, 180, 270, 360, 450, 540, 630, etc. 720. We keep going. When you're doing the quadrantal angles, it doesn't matter if I go out 10 or I go out 5. We can reduce all of it 1 to just 1. Use r equals 1. When r equals 1, this is called the unit circle. In mathematics, when you see unit anything means 1. So this is 1, 0. This is 0, 1. This is -1, 0. And this is 0, -1. Let's look at 90 degrees and 180 degrees, 180 degrees. So the 90 degrees. The process is similar for all of them. Sine of theta, we know the unit r equals 1, so it doesn't matter. Everywhere we have r, Sine theta is y over r, which is just y, which is 1. Cosine theta is x over r, which is just x, which is 1. Tangent theta is y over x. I'm sorry, x is 0 right there. What the heck did I? Yeah, I got it 90 degrees up here. X is 0. Tangent theta is y over x. This is 1 over 0. Tangent of 90 degrees is undefined. Maybe I should write sine of 90 and cosine of 90. Whether you put the parentheses or not, some people do, some people don't. And we can look at the reciprocals. Sine goes to cosecant. Cosecant theta is r over y, which is still 1 over 1, is 1. Secant theta is r over x, which is 1 over 0, which is undefined. And cotangent theta is x over y, is 0 over 1, which is 0. And again, I should have wrote, instead of putting in theta, cosecant of 90 degrees. Secant of 90 degrees. Cotangent of 90 degrees. You guys give it a try for 150. Or sorry, not 150, 180. So pause it and try to work them out. (180 degrees is back over here, negative 1, 0. So x equals negative 1, y equals 0, r equals 1. Sine theta is y over r, which is 0 over 1, which is 0. If we flip that over, cosecant theta is 1 over sine theta, which is 1 over 0, which is undefined. I'm going to put the 180 in now. Cosine of 180 is x over r, which is negative 1 over 1. It's negative 1. And we do the reciprocal of that. We got 1 over cosine theta, or 180 degrees, which is 1 over 1. I'm sorry, that's negative 1, which is still negative 1. And tangent theta is y over x, 0 over negative 1, which is 0. The reciprocal or 1 over tangent theta, so 1 over 0 is undefined. So we can make a little table. You should have all of these memorized, okay? By the end of the week 2, this is only a 4-week course because it's summer. In a normal semester, by the end of the first test, or when the first test happens, you should know. So we're going to put angle. We've got 0 degrees, 90 degrees, 180 degrees, 270 degrees. And this is also 360 in all the coterminal angles. It actually follows a pattern. The zeros alternate. Zeros alternate on tangent, but the other ones here are undefined. And it's easiest to get this one just by doing sine theta over cosine theta. You memorize sine and cosine, you can work out tangent real quick. So let's take a look at more of what's going on here. Let's do some more analysis. So we got our circle here, our unit circle. Here we go 90 degrees, another 90 degrees, another 90 degrees, another 90 degrees. So this is 180, 270, and 0 degrees is also 360. Let's look at what's going on in each quadrant. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. What sign are the trig functions in each quadrant? For the unit circle, r equals 1, so sine theta equals y, cosine theta equals x, and tangent theta equals y over x or n, the slope from algebra. So let's look at each quadrant. Q1, Q2, Q3, Q4. I did 1, 2, 3, and then I wrote 4 up here in regular numbers. That was lame. And in each quadrant, I'm going to look at sine, cosine, and tangent. Because in each quadrant, they don't change. Anywhere in that quadrant, they stay the same. In quadrant 1, x is greater than 0, y is greater than 0. Sine theta is y, which means sine theta is greater than 0, which means it's positive. Cosine theta is greater than 0, which means it's positive. And tangent theta is sine over cosine. It's also positive. All are positive. We come over here. X is less than 0 now. Y is still greater than 0 in quadrant 2. So sine is still positive. Sine is greater than 0 because it's y, which means positive. Cosine is less than 0, which means negative. So tangent theta is positive over negative, it's negative. In quadrant 2, sine is positive. Quadrant 3, we've got both of them are negative. So this is less than 0, that's less than 0, which means both of these are negative. And a negative over a negative is a positive. In quadrant 3, only tangent is positive. And finally, in quadrant 4, here we've got x is now positive, but y is negative. Because remember, this is 0, 0. Anything above it's positive for y, below it is negative. Left of it is negative for x, right of it is positive. Less than 0 is negative. Cosine of theta is positive, it's to the right of the origin. That's negative over positive is negative. Only cosine is positive. Now that's a lot of stuff to remember right there. Let's give you an easier way to do that. I'm going to leave that up here while I make my picture down here. The way to remember this is remember the positives. That's a good approach to life. Remember the positives. In this region, it's A for all. S is for sine. Sine's positive in quadrant 2. Tangent is positive in quadrant 3. We'll use T. And C is positive in quadrant 4, cosine. So, going around the circle, counterclockwise, the way angles go positive, A, S, T, C. Now, I've seen a lot of acronyms, mnemonics, to memorize these. I've seen a lot of mnemonics. A math one I've heard, ASTC, all students take calculus. We know this is not true. This is a common mnemonic or memory tool. But it's completely false. You know, I know my brother didn't take calculus. All I need is one counterexample. My brother didn't take calculus. He's a plumber. He's a journeyman plumber. He makes more money than I do. Didn't even have to go to school that much for it. The trades are very good business. You know what is true though? You know what's true everywhere? The way you'll remember it, all strippers take cash. True story. You will not see a stripper turn down money. If you want to take it a little different route, all students take cash. I don't know a student that'll turn down money given offered it to him. You know another one I like? This is another clean one. All siblings are trained chimps. Yep, my brother is a trained monkey. I like that one. I liked siblings are your brothers and sisters. Gives you an opportunity to talk shit about your family. It's good times. Good times. Good stuff. Okay. We're almost done with this section. We should look at the ranges of the trig functions. Oops. Ranges of values for trig functions. And so these are the y values. Range is related to y. And we're looking at the unit circle. The radius is always 1. So both sine theta and cosine theta, their lowest value is -1 and it includes it. The biggest value is +1 and it's inclusive. The bracket says include the value. Remember that from algebra? Parentheses say don't include it. Parentheses are don't include. When you flip these over, you end up getting these. Cosecant theta and secant theta. Everywhere in between here is a decimal. In between is a decimal. It's always smaller than 1, which means when you flip it over, if you put like 1/2 on bottom, it becomes 2. It becomes bigger. So this can go all the way up to -infinity when we're at the bottom. And it can go all the way up to -1. It includes -1. And it can go from 1 to infinity. Both cosecant and secant are that way. And that's where the parentheses parts come in. Tangent theta and cotangent theta have the same ranges. Since we have any decimal form in between, we can put cosine theta as 1 all the time on bottom. Or no, let's make sine theta 1 all the time on. Yeah, it varies. If sine theta is 1 and cosine theta is a small value, we're looking at things bigger or less than 1 and -1. If cosine's 1 and sine is small, we have all the values between -1 and 1. Tangent theta and cotangent theta can be all real numbers. Okay. Finally, the identities. Pause it if you need this. The big part to remember is these. When we start graphing them, you'll see these. You need to remember sine and cosine is less than. Remember, sine and cosine are between -1 and 1. Inclusive. You can include -1 and 1. That's the biggest message on this page. Okay. Let's look at some of the identities. If you need to, pause it, rewind a little bit, pause it, and take the notes you do need to. Some more identities. And you know what? You can, let's derive them. If you know how to derive them, you actually don't need to memorize them. They all start with x² + y² = r². Okay, so for option A, divide by r squared. But this is x over r squared plus y over r squared equals 1. This is cosine theta squared plus sine theta squared equals 1. And generally when we square it, when we have powers of trig functions, this is not a common notation for exponents. Instead, we put it between the trig function and its angle. Alternatively, I don't know why I remember sine squared theta first. Both of these work. I just changed the order of them. This is one of the identities. This is the base identity. Base identity. I don't think that's the official name, but everything else comes from it. Okay. Let's call this equation A, sine squared theta plus cosine squared theta equals 1. For B, start with A, divide by cosine squared. Sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta plus or equals 1 over cosine squared theta. Sine over cosine is tangent. Cosine squared theta divided by cosine squared theta is just 1. And 1 over cosine squared theta is secant squared theta. So this will be equation B. And guess how we get C? C is start with A, divide by sine squared. Sine squared theta over sine squared theta plus cosine squared theta over sine squared theta equals 1 over sine squared theta. We get 1 plus cotangent theta or cotangent squared theta equals cosecant squared theta. These three functions or three equations, these are equivalent, so they just count as 1. These three equations are called the Pythagorean identities. And why? Because they stem from x squared plus y squared equals r squared. That's the only identities that we'll do in this section. There are problems with it. So some problems you'll see. Pause it if you need to. Let's look at some examples though. Use identities to find sine theta and tangent theta given cosine theta equals negative root 3 over 2. And sine theta is less than 0. That last part is an important piece of information. Because cosine theta is x over r. And r is always positive. So we know r equals 2, which means x equals negative root 3. But that's true in quadrant 2 and 3. That applies to both. Sine being negative tells us it's down here. So drawing a picture helps. So we've got r equals 2, x equals negative 3. There's a couple ways to go about it. You could use the Pythagorean formula to find y, but we're not. We're going to use the identities like it said. Sine squared theta plus cosine squared theta equals 1. And we know cosine theta is negative root 3 over 2. We square that, negative root 3 squared is 3, and 2 squared is 4. Subtract 3/4 from both sides, and we get sine squared theta equals 1/4. We take the square root. Sine theta equals plus or minus 1/2. And now use sine theta less than 0 to help narrow it down. Sine theta is less than 0. It means it's the negative 1. Sine theta is negative 1/2. So that was an important piece of information. We need tangent now. We can use sine over cosine, but I'm going to use the identities. Cosine theta is negative root 3 over 2, which means secant theta is negative 2 over root 3. And you come back, you look at your formulas. Looks like we're looking at this one. We've got secant already. We're looking for tangent. That's how I determined I needed secant. I want tangent, the identity that has secant in it. So I'm going to find secant by flipping cosine. Tangent squared theta plus 1 equals secant squared theta. Tangent squared theta equals, I'm going to subtract 1 from both sides as I put secant squared in. Negative 2 over root 3 squared minus 1. Four over 3 minus 1. Need a common denominator. 1 turns into 3/3. So this is 1/3. Tangent theta is positive or negative square root of 1/3. Which one is it? We're in quadrant 3. Tangent's greater than 0 here, and sine was less than 0. So we want the positive one. The positive square root of 1 is 1. The square root of 3 is the square root of 3. We don't leave it like that. We rationalize it. Root 3 over 3. And there we've found sine and tangent. And obviously finding secant and cosecant. Well, we already found secant to do this. If I were doing this, I probably wouldn't use identities. I might use identities so I don't need to draw the picture. But I think drawing the picture really helps you get the signs. Is it positive or negative? Okay. Rather than memorizing what's positive and negative by quadrant, drawing the picture is an easy way of remembering. That's it for 5.2. I hope you're enjoying yourself. And I'll get some more videos done today, but I'm going to go eat lunch. Peace. C'est la vie.